So in this video we're going to be doing another example, just quite like the last example. It's going to be slightly different. We're going to be using still definite integrals to calculate the area under a curve. So if you want, you can pause the video, try and work through the problem, and then there'll be the answer or the timestamp for the answer in the description. So you can click on that, it'll skip to the bit of the video with the answer. You can check if you're right. Otherwise you can just sit back and watch the video and hopefully understand it by the end of the video. So I'm just going to go ahead and start this. So we want to find A and B, so these points here, and hence find the area between the curve and the x-axis. So I have written up here the area under the curve. It's not necessarily the area under the curve, it's just easier to say that than area between curve and x-axis. But when I say area under a curve, generally that's what I mean. I mean it's the area between the curve and the x-axis, because that's exactly what integration does, because obviously the area under the curve is just going to all of this area down here, so there'll be quite a lot of area, but it's always between the curve and the x-axis. Okay, so I should have clarified that, but hopefully it makes sense, and it's just easier to say the area under the curve. So we can't find that until we know the limits of integration, the points A and B. So we're going to need to find those first. So I'll scroll down, I'm going to do this in purple. The way we're going to do that is we're just going to go back to our algebra. We're going to find the roots of the equation. Okay, so if you remember solving quadratic equations, we're going to have to put them into the brackets like this, let it equal to 0. So in this case it's going to be 1 and 4, it's going to be minus 4 and plus 1. Okay, so that means x is equal to 4 or x is equal to minus 1. Ooh, there should be minus there. So obviously a is equal to minus 1, because that's the one that's in the minus part, and then b is equal to 4. Okay, so now that we have that bit done, we can start looking at integrating it. Okay, so we can integrate this definite integral, limits of integration are minus 1 and 4. So I'll just scroll down, I'm going to do this in bright blue. So it's going to be the integration of between minus 1 and 4 of x squared minus 3x minus 4 dx, and a is going to be equal to that. Okay, so a being our area. Okay, actually I won't use a, I'm just going to say, let me go back here, I'll say area because we already had a up there. Area is equal to this, yeah? So that's going to be equal to x cubed over 3 minus 3x squared over 2 minus 4x evaluated from minus 1 to 4. Okay, and after this now it's just normal definite integrals. So that's going to be 4 cubed over 3 minus 3 by 4 squared over 2 minus 4 by 4, one bracket, minus, and be careful about the minus 1 here, because the minus 1 will affect it. Sorry, it's another bracket there, so that's supposed to be the 1, over 3 minus 3 by minus 1 squared over 2 minus 4 by minus 1, big bracket. Okay, stick that into your calculator and you're going to simplify that down to minus 56 over 3 minus 13 over 6. Okay, so you're going to notice something about this answer now. This answer overall is either minus 20 and 5 over 6. I don't really like writing it like that. I prefer writing it as one big fraction. So it's minus 125 over 6. Okay, that's our answer for the area under the curve. But obviously that's a minus answer, so that doesn't make any sense. The reason for that is because it's underneath the curve here. It's underneath the x-axis here. So the other example, we had an n-shaped curve. So when we got the area, it was a plus answer. Here, since it's below the x-axis, it's going to be a minus answer. So basically what you do is you just get rid of the minus. You just say, oh, well, it's a plus because it was under the curve. So you don't need to give a reasoning for that. You can just say, therefore, the area is equal to plus 125 over 6. So I'm just going to do that. I'll finish it off in orange. Then I'm just going to say, this implies, or therefore, area is equal to plus 125 over 6 units squared. And the reason you say units is just because you don't know. If it was centimeters or meters, you'd say centimeters or meters squared, but since we don't know, we just say unit squared. You don't have to be so worried about saying unit squared. I don't think they're going to mark you down for not saying it, but it is just good to know that you understand the area is always unit squared, okay? Plus 125 over 6. So hopefully you got that if you paused the video. There's our answer, and if not, you can look through the video and see where you went wrong. And that's generally, it gets more complicated, but it's always the same basic idea. You're just integrating using a definite integral between your limits of integration. So again, hopefully that makes sense, and we're going to look at harder examples now next time. Okay, it's going to be more integrations under curves.